Hey, welcome back. Glad you could join me today. Today I want to talk to you about something that's near and dear to my heart, chemical reactions. Actually, if you think about it, they're near and dear to your heart too, because without chemical reactions, there would be no life. There'd be no phones, there'd be no TVs, cars, anything of that sort. So let's start off with a quick demonstration of a chemical reaction. I'm going to take this. I've got some, I'm going to take this liquid here. I've got some pH indicator. It's going to tell me how strong or how weak the acid is. Just a little bit in there. Now you'll notice it turns green, kind of a greenish color. That's because this is a base. It is the stuff that you use to clean windows. It's the active ingredient in Windex. In here, I have some acid. Watch what happens as I add a little bit of this to it. All right. When all else fails, you drop back 5 yards and punt, right? What's supposed to happen is it was supposed to turn pink. I guess I had a little too much water or too much acid in there, or not enough acid. So having said that, let's try something else. I'll come over here. And for those of you that have been in my class, you know what this is. This is called the Whoosh Bottle. Take some of this. Excuse me. Pour a quantity in there. Set it down here. Now then, I'm going to swirl this around, making a vapor. Might want to add some more. What I'm putting in here is rubbing alcohol, just like you buy at Walmart or whatever. Now, ladies and gentlemen, boys and girls, don't try this at home. Don't do this at home. I've had a lot of training in how to do this. If you don't do it right, you can cause some bad problems. So I'm going to swirl it around, make sure the sides are coated and it's vaporized. Now then, I'm going to pour out the excess alcohol. Now, please note, I'm pouring it out. Turn it around here like this. Are you ready for this? That is a combustion reaction. I'm taking the hydrocarbons from the alcohol, combining them with oxygen to form two different compounds, forming carbon dioxide and water. Now remember, I poured the excess alcohol out. Watch this. There's the water. Now I know everybody wants me to do it again, do it again, do it again. Well, I can't. Not right away. See, that bottle is now full of carbon dioxide. So carbon dioxide is heavier than air. So it has replaced all the air in that bottle. I have to take and tip it up and let it drain out for about 45 minutes before it will work. Another thing that we can do now then, in here I have some metallic sodium. Now, people say, well, where can we get this? Where can we get this? You have to have a reason to get it. And you'll notice that I'm using a pair of tweezers to pull it out. That's because this metallic sodium reacts violently with water. I'm going to run some water in here real quick. Now, I said that this was metallic sodium. properties of a metal. It's shiny. It conducts electricity and heat. It's malleable, which means we can take and hammer it into a thin sheet. But you're looking at this and say, well, Mr. Harshfield, that doesn't look very shiny. Sodium is a soft metal. I can take the scalpel and cut it, and here you can see how shiny it really is. But you'll notice that it turns that gray color very quickly. It's reacting with the oxygen in the air to form sodium oxide. Now, I said that it reacts violently with water. That's all right. Remember, I poured the alcohol out in the sink from the previous demonstration, and that sodium, when it sparked, ignited that. That's why I say don't do this at home. Don't even try it. Again, you notice I use tweezers for this. That's because that sodium is so reactive that it will react with the moisture in my hands. Now, everybody's heard about elephant's toothpaste, I assume, right? All right, let me get this out of the way. I'm going to take and pour a little dish soap in here. I'm going to take some hydrogen peroxide and pour in here. Now, the peroxide I'm using is about 6%. What you would buy at Walmart is about 3%. Now I have a chemical, this potassium iodide, and this is just a liquid. As you can see here. Now watch what happens when I add this to the flask. We've got a chemical reaction going. It's slow, but it is building. There you can see the reaction. You can see that soap film building. I put that soap in there because that's one indication of a chemical reaction. Yeah, there it comes. It's slow. I know you've seen it on TV where they pump it in and it just goes woof. Probably what they're doing is they're using a stronger hydrogen peroxide. They've got a different catalyst that they use. Oh, catalyst. Definition of a catalyst. It's something that helps the reaction go, but it doesn't take part in the reaction itself. All right. So you've been talking chemical reactions, Mr. Harshfield. What do you mean by chemical reaction? A chemical reaction is where a substance or substances are put together to form something new. There's actually 5 or 6 different types of chemical reactions. The first type is a synthesis reaction. That's where we take 2 substances, put them together to form something new. It could even change the chemical properties. For an example, you saw the reaction of the sodium in the water. So, and if we took and combined that with chlorine, now chlorine is a deadly gas. They use it to sanitize water for like swimming pools and drinking water. We put those two together, and it forms a substance that we have to have for life. What do you think NaCl really is? It's sodium chloride. It's also known to you as table salt. So next time you put salt on your French fries, remember, you're eating sodium and chlorine. The next type of reaction is a single replacement. That's where one element, and I'm just going to call it A. So element A is going to combine with an element or a compound BC, and it's going to form a new compound AC plus B. The element A is going to replace the element B. How do I know that? These are cations. Cations are the ones that do the replacing. Easy way to remember a cation. Think of a cat. What does a cat have? It has paws. So cats are positive. Cations are positive. And if you stretch a cat out, it's going to look kind of like a plus sign. So that's a nice, easy way to remember that. The next type of reaction is a double replacement. And this is a case where compound AB is going to react with compound CD to produce new substance AD plus CB. My favorite example of this. Sodium hydroxide reacting with hydrochloric acid. Guys, tell you a little secret. Hydrochloric acid you carry with you every second of every day. That's part of your stomach's digestive juices. And it is so strong that it will actually eat metal. And I can tell you why it doesn't in a little bit. But what that's going to do is the sodium and the hydrogen are going to switch places. So now we have sodium chloride plus dihydrogen monoxide, also known as water. We could write that as this. I love that reaction. That reaction is so important to everybody. The next type of reaction we have, combustion. In this case, we're going to take a hydrocarbon, something that has hydrogen, carbon, and oxygen, combine it with oxygen, provide some heat. And that little delta, that little triangle there in chemistry means heat or change. And we're going to form this. Again, this is water. This is carbon dioxide. And so that bottle, that Whoosh bottle that I did, is now full of carbon dioxide. Let's see, synthesis, single reaction, double reaction, combustion. Oh, I remember. Decomposition. That's where we're going to take one substance and break it down into two or more new substances. We can take water, apply some energy, and we can break this down into hydrogen plus oxygen. Yeah, I know. Some of you are saying, well, that's not a balanced equation. Remember, a balanced equation means that everything going into the equation has to come out. So to balance it, I'm going to put a 2 here and a 2 here. So now we have 4 hydrogens on this side, 2 oxygens, 4 hydrogens, and 2 oxygens. So now it's a balanced equation. And one of the things I do in my class is I have a device that we can actually do this and determine which is the hydrogen, which is the oxygen. Now, along with this, there are subsets of each of these. One subset is an endothermic. That is a reaction that actually pulls the energy out of the system, out of the environment, and so it's going to feel cold. If you experience an injury, like you sprain your ankle on a football field, and they put that pack on there after they shake it up, that's an endothermic reaction. It's cold. It's going to pull the heat out of your muscles. Another one is an exothermic reaction. That's one that's going to produce heat. It can produce a little heat. It can produce a lot of heat. If I took some sodium hydroxide in solid form, add it to water, mix it up, and let it sit there for a minute, it's going to get extremely hot. The chemical bonds are being broken. The things that hold those atoms together are being broken. And when that happens, it releases energy. I said that chemical reactions are important to life. Think about this. What did you have for breakfast this morning? Well, let's see. I had a couple of granola bars. I had a banana. I had an orange. For lunch, I'm probably going to have a salad. For dinner, I don't know what I'm going to have yet, but they all go in. Now, why would I take in food? I take in food for the energy that it produces. These chemical reactions breaks that down, releasing that energy, making that energy available for me to use. Wonderful things. Your car operates on chemical reactions. It reacts in a combustion reaction. Each time that cylinder is pushed down, each time that spark plug sparks, that's an explosion, a controlled explosion, a chemical reaction. Now, please don't think that carbon dioxide as dry ice, which is carbon dioxide in a solid form, is a chemical reaction going to carbon dioxide as a gas. It's not a chemical reaction. It's the same compound, just changing its form. Just like water, when we have ice and we let it melt, it changes into liquid water. That's not a chemical reaction. That is a physical change. It's changing its form. When it goes to steam, that's a physical change. It's changing its form. So, once again, chemical reactions. We have the synthesis reaction, simply means putting things together. We have a single replacement reaction in which things are changed. One item, one compound, or one element is changed for another one in a compound. We have double replacement where two of them are replaced. We have decomposition, in which we take and pull those compounds apart. We have combustion, in which we combine that compound with oxygen to form something else, breaking it down, recombining it. All these things go into chemical reactions. Let's see, I had one more thing. Oh, before I forget, this right here, this is what's called a pH indicator. It tells me how strong or how weak an acid or a base may be. So remember, in this beaker, we put the sodium in. If I put just a little bit of this pH indicator in, it turns green. This pH indicator will turn green when it's in a base. If we put it in an acid, it turns pink. So we can tell by how much of the acid or base that we have to add to get a color change, that we can tell how strong it is. One last thing before I go. The way we can tell a chemical reaction has occurred, first of all, there's going to be a change in color. We saw that here. There's going to be production of heat or light, change of energy in some form. There's going to be production of gases. Think about pouring sodium or some baking soda into vinegar. What happens? It foams up. It foams up because it's producing gas. It's producing carbon dioxide. And then we have, let's say we have change in color. We have a change in the energy of the system. We have production of heat or change in state. For example, it could go from a liquid to a solid. Some of these reactions, when they react, are going to form a solid. Even though we start out with two liquids, we can have a production of sound, production of gas. All these things are going to indicate that we have a chemical reaction. That flame is a chemical reaction. I'm combining the hydrocarbons that are in this with the oxygen. Over here, you can see that we've had a chemical reaction. We've had a production of gas with the sodium. When we put the sodium in water, remember the sparks that flew? A change in the energy of the system. When I had that sodium sitting there on that watch glass, it just sat there. But I put it in water, and it's going to be a reaction. So the next time you look out and you see something, you see a car, you see a car moving, or a car just sitting there, you see animals, even plants, you play with your Xbox or you watch TV, think about all the chemical reactions that went into that particular item. Nothing exists without some sort of chemical reaction occurring. So, once again, I thank you for joining me. I hope that you have a pleasant summer, a safe summer, and I look forward to seeing everybody back in school in the fall. So, thank you once again for allowing me into your home.